Hello. Hello. Please respond on the chat whether you are able to hear me. Yeah, thanks. Good afternoon and welcome to this session on analytics, where we are going to discuss some of the practical applications related to our program and how we would be dealing with the classes. Initially, let us understand what exactly analytics means. Analytics is essentially the transformation of data to meaningful information and then transforming that meaningful information to insights for better decision making, offering new opportunities for competitive advantages. So analytics is essentially about doing descriptive analytics, where we describe the essence of a problem. After deciding the problem, we essentially, after deciding on the problem, we essentially describe what the problem is all about, and getting insights of the data and describing about that is what is descriptive analytics. And then we go and do predictions on the data, which we call as predictive analytics, where we predict. When doing predictions, so we essentially have to have historical data. So when we have historical data, we would typically like to analyze the historical data and then essentially predict future events based on the historical data. Usually historical data anywhere between minimum 6 months to almost about 3 years is what is the basic requirement. And then after taking this whole lot of data, we normally go and make the predictions. That is what is predictive analytics. Now, for any this thing prediction that I have given, there needs to be a decision that needs to be taken. That means once I have made a prediction that this event is going to happen, there needs to be some action that has to be taken towards that. And for taking that, I give a prescription talking about actions that need to be taken to achieve that particular prediction. And then in health analytics, we have one more which is called as diagnostic analytics, where I diagnose the issue and then we go for the prescription, and then we go and do the actual treatment and things like that. So this is what is a brief about what analytics is about, what are the types of analytics, and to get to some of the practical aspects of analytics. What exactly does an analyst do? Let's take a very simple example. Let's take that I need to improve the sales at a particular shop. So, what we need to understand is we are trying to increase the sales. That means we are targeting customers. When we are targeting customers, essentially we need to tap the right group of customers. So for tapping the right group of customers, I need to identify what is the customer database this person is having. And once I move through the data, I will be able to identify the right set where sales can be improved. Essentially, we do what is called as customer segmentation here. In customer segmentation, I would remove what is called as the recent customers and the frequent customers. Recent customers are the ones who come once and I don't know when they are going to come back. Frequent customers are those who frequent once in 2 months, 3 months. They come a little often, but then they are not my money spinners and not the business drivers. And rest of the 20%, final 20%, 80% of customers are consisted of recent and frequent customers, while 20% are my monetary cash cows who are driving my business. So who come month on to me and then take month on month to me and then they make transactions. So essentially, the monetary customers are my customers to be targeted. So what I do is I target the monetary customer, which are 20%. I target them. Out of that 20%, who are the ones who are going to help me presently to get the revenues at this point of time is what I predict. And then based on that, I approach these people and then I can increase the sales with these people, which essentially reflects in increase in revenues, increase in the same, and this is applicable to all businesses. Let us take one more example at this point of time. So in the first example, I have targeted the monetary customers. In the second example, let's look at products on a shelf. The best example which we normally talk here is about the beer in the diaper. So this problem is related to Unimart in the US. This is a very good example to understand. To understand in analytics, it is not basically the mathematical model and the statistical model, but also a lot of thinking goes into the whole stuff. So to be an analyst, you need to be a very good. Your thinking needs to change. Perceptions need to be very accurate, and it is also that with perception, your thought process should be unbiased. Say, for example, let me, for driving the point of unbiased, let us take the election exit polls being the best example. Everybody works with the same example, everybody works with the same database, most of them fit almost the same, decently same models, and even after that, each one of them get differing results in comparison to what they actually get after the results are announced. Why did this happen? The essential point here is that Each one of them took the same database. They follow the same standards. We normally use the CRISP-DM framework in all the cases. We follow specified steps and then we arrive at the predictions. Only change will be models may be changing because one may be using linear regression for the prediction, one may be using multiple regression. So models do not give the differing results, far differing results, but similar results. But then it should not be so different that it changes the whole prediction itself. So perception holds the key. So when perception and unbiasedness in the decision, you will be able to see all the information. When you are having biased this thing, so obviously predictions go wrong. So that is a key. That's the key. Thinker's job. It's more a thinker's job rather than being anything else. Another very important aspect that we need to understand is that perception goes on a long way. Perception goes a long way in understanding the data, and once data is understood, we will be able to map to what prediction results we may get at the end, intuitions. So that's the thing where our perception holds the key to the whole process. So coming back to the beer and diaper example, essentially this is a case of Unimart, which is given in many different forums, and many different people use the same this thing to drive this point. And what happens is these guys are placing they want the sales to increase for these two products, essentially. So when the product sales has to be pushed up, these guys are situated in the US. So part of the data that is given to you is they say that 98% of men visit the shop, while it's only 2% of women who visit the shop. So this is the first set of data that is given. And once you read through this data that it's 98% men, then why beer is not selling may be a very typical question. But then even though there may be 99% of drinkers across the US. So now this is one thing. Second, most of the sales happens only during the weekends. This is the second set of data that is given in this example. And the third set of this thing is trickles of sales happens during the weekdays. How do you really think of getting a solution to this even without fitting a model to this? I want you to think about this. Maybe I would like you to be a little interactive by typing a couple of words there on the chat and tell me what do you really feel about this. No takers on that? Okay, essentially the thinking and the perception should also come from the cultural setup of the place and from where the data set comes in. I told you this thing that the data set is coming from the US. So that means I need to consider the cultural setup of the United States. So when we look at the cultural setup of the United States, the culture there is totally different than what we have in our country. Woman in a relationship, they push their man because they also work throughout the week and they want their man to do the errands at the shop. So this guy comes and whatever he wants, he will just pick up and he will go. So the best solution that is given in this particular example is to place both the products closer to the door. And most of the time it is observed that these guys spend only about 15 to 20 minutes at the shop because they also on the weekend, they either want to sleep or they want to go on an outing or they want to party. These are the three things the people do in the US essentially. So basically keeping that in mind, people have suggested that products may be put together closer to the door so that they pick up both the products and they leave depending on the requirements. So when we place the products together and closer to the door, the sales have increased essentially. And this does not need a mathematical model. And people who worked on this project long ago, I heard that they first worked on the solution, they got the sales up, and then went back and reworked on the statistical model, which was supposed to prove that this really works. So essentially, what I'm trying to say is every problem need not have a mathematical model or a statistical model that is associated with it. And it need not carry that this thing. So we may have a solution first and then rework on the problem also. So it's more a thinker's job. That's the point I wanted to drive, that it's more a thinker's job. Perception, unbiasedness is what is the key requirement to the whole thing. Apart from this, other additional things that you typically require is it is something like being jack of all trades. So you need to, for doing your tropical analytics or drawing your technical tropical analytics techniques, you need to know statistics. Mathematics is the base. Domain expertise is to know about pattern recognition, data mining, and then for doing the essential business analytics and automations, we normally need to know about machine learning, and then to do the stakeholder management and things like that, where we talk about automations apart from the this thing is neural networks, artificial networks. Data visualization is required for showing the data in a picturized format. Simple example of data visualization may be, even though the company suffers a loss, normally if I have investors in the company, I cannot go and project that I had a loss and things like that. So you project it in a different fashion. So you have specifically programmers like who do work on Tableau, Power BI, and things like this to project the positive things that have happened as a picture, so that people, once they look at the images, they will be able to understand. But as a data analyst, I also need to know this. Maybe I may not be a good creator essentially, but then to picturize data, this would be essential. And then doing the hypothesis testing, which is also part of statistics. Essentially, we use that as part of the storytelling ability of the scientist. And then business communications are done through data modeling, big data engineering solutions, exploratory data analysis is done for consulting and For problem solving, we use modeling and predictive analytics. This is what is a whole gamut of things that a analyst, business analyst, or a data scientist, or a decision scientist, as today's world calls the same. Uh, we we need to know this. So that was about a brief about what analytics was. We had a definition for those who joined late. I'd like to just reiterate the points so that we defined what was analytics. We took in a few live examples to demonstrate about analytics. We draw in the point pertaining to perception, the unbiasedness in thinking, and more of a thinker's job was what was the point that was driven. And finally, the whole set of knowledge that you need to have to be a data scientist. Now, in the initial stages of the discussion, I said everybody follows the same steps. So there is a standard that is followed in the industry, which is called as a CRISP-DM framework, which is called as a cross-industry standard process for data mining. So there are about 6 steps in this, and the first step is to understand business vertical. As a data scientist, I cannot say I'm not a mechanical engineer or I'm not a automobile engineer, so I don't understand this data, or I don't understand this domain, so I would not do this project. And being working professionals, you know that we cannot refuse. And so what we normally do in the first step is to understand the business vertical. So we go prepare ourselves, understand the entire business vertical, how the vertical works, how exactly things are going on in that particular domain. And then we spend a whole lot of time on that, depending on the time we have in the project. Normally anywhere between a week to even about a month's time is spent on learning about the business vertical, because unless I know the key aspects of the whole business vertical, I will not be able to make my predictions. It is as similar as an astrologer making predictions. So he also relies on a lot of historical data, which he reads through the horoscope and then finally makes a prediction. So in a sense, there is a lot of historical data that is key to the whole process. So the next step is to understand whatever data is given to us, identify patterns in that, identify the key aspects of what is the real essence of the data. And once you have understood that, we will be able to make an intuition of what to expect at the end. Maybe it is wrong or right. Another very important aspect is to understand there is no right or wrong data. There are wrong answers to answers in analytics. Essentially, it basically depends on the data that we get. Point number one. Point number two, perceptions and thinking capabilities of different people are at different levels. So essentially, is bound to be difference. And since we are using statistics as a tool for analytics, we need to identify that statistics is a very approximate, a decently approximate science, not very exact like mathematics. So when I give my data, my predictions are going to be a little here and there. And that is why in that election example, when we say one guy says this guy is going to get more than 300 seats, this guy is going to get 270 seats, this guy is going to get 160 seats. Same data, similar type of model was applied, similar type of this thing was applied. But then when I understood my data, I have a different perception of looking at the things. So when I get my most significant variables at the end of the prediction, my mind is already biased and looking only at those biased data points and not at the whole data, which is actually giving me the key answers for the predictions. So I failed to look into it. So understanding the data and then mapping it to our thinking and then intuiting is also something very important. The third stage is to prepare the data. I just got some raw data. It can be in different form, but then certain processed data, structural formatting needs to be got in. That's the first step. Second step is to look for missing values. There may be a lot of missing values. When data is collected, not all the data is there. Some of the variable values for some of the records are missing. So in a key sense, we do missing value treatment using statistics. And when we do that, we use mean values or the median values, which is the central point of the whole data set. Median, when I take it, is the centermost point. After sorting, I take the centermost point, take that value, and then I'm substituting it for the missing values. So when I substitute it with the median value, mean will obviously change a little bit. Or either I put the mean and then I try to do the whole aspect of things. It is going to change to a certain extent. Point something will change. So there is going to be a little bit of biasness in my decision there. So what we normally do in real time when my data records are huge, missing value records, I normally delete them. Supposing I have lesser than 1000 or lesser than 600 records, that is the point of time when we try to work on the missing values. Else in real-time data where we work on 5000, 6000 records, 1000 records are missing, we just remove it and prepare the data. And then, of course, outlier treatment needs to be done, which sorts or which sees that data comes into a normal form. So data needs to be under the curve. That means there is no skewedness of data. There's no biasness in the data that has come in. Supposing if the data moves towards the left, most of the data points are towards the left side of the graph instead of being normal under the bell curve. We call this as left skewed or either right skewed or negatively skewed. If it is on the other side, we call it, if it is towards the origin, we call it as right skewed or positively skewed. So that means we are going to get biased results. So for example, if I have a plot for say age groups of say from 10 to around 90, and I plot for their diabetes. So those who are probably around the age above 50 and above may be having diabetes. So that it is going to be concentratedly on the left-hand side of the thing. It's going to be left skewed or negatively skewed. For those between the age of 10 to 20, it will be at the other end because they don't have diabetes and they're at the lower end. When I say normal, if you take some time back, doctors used to say that 220 and above is you are diabetic. Then sometime later they started saying it is 160 and above. Today, most doctors are saying it's 150 and above you are diabetic. Maybe as per the medical fraternity statements itself, you can find that most of this is more of a money minting racket rather than really this thing. I said an approximate science. statistics being an approximate science. See, every body has got its own body weight, has got its own BOD, has got its own COD, and all these parameters. So I may not be diabetic at 150. Somebody else may be diabetic at that level. So those type of parameters are not being considered, but then we are we are trying to essentially take an average and then trying to say that all these guys have that. So it's just a plotting, and then of course some experimental sample has been taken, and then we have calculated some correlation value which approximated between 0.7 to about 0.9, and then we said this the guy is having diabetes. So it's more approximate rather than being very exact and saying yes, this guy has, but then the doctor says you are having diabetes. That's how the whole scenario looks like. So most of the time what we try to do is try to contract the points as much as possible. If there are outliers, we try to vomit them if we have huge data set, or then treat them and try to get them to what we calculate from the data set as the statistical maximum value, substitute that, and then make the whole data preparation. Take this data and then give it into a model. And if I'm doing normal predictions and things like that, we normally go for the regression techniques. It may be linear regression. If you are trying to classify something like yes and no, if there are only two categories of classification, then we go for a simple logistic regression, which is a classification algorithm. And then in further classification algorithms, you can have a lot of classes. Say cancer stages can be example for classification, and then you can have clustering for more precise results. That's what we do. We use the k-means and the KNN algorithms, and we try to put the whole lot of models there depending on our problem statement. So we need to have an identification. So by the end of the program that you would undergo with us, I would be taking you up to the clustering algorithms in the basic programs, while on the advanced programs we do have other algorithms like random forest, Bayesian Bayesian networks and things like that. So the key lies in understanding the concept. Once your base is strong, my belief is always that you can go and build on that. So understanding the steps in building basic models and then going ahead and learning the advanced is pretty simple, and that you can do by yourself. So once the model is fitted, you need to evaluate the model, check for its correctness. Based on the problem, we fitted some model, whether it is working in that scenario or not. And if it does not work, I have to go and select another algorithm. Most of the time in real time, we end up fitting 3 or 4 models and then take the most accurate one or most this thing that is nearing towards 0.9, and then decide on and predict on based on those both those factors. So once the evaluation is done, I would finally deploy it wherever it needs to be deployed. So this is the steps we normally follow on a CRISP-DM framework. So once having this basic idea of what exactly analytics is all about and what exactly this whole thing holds in key for us, let's do understand some hands-on activity so that it would be very complementing most of the time. What we normally do in our sessions is talk, give you a brief idea of the whole concept, and then make you implement it with a series of instructions. And that's how I do it. So, in the meantime, when I'm giving you a brief introduction to R, probably what you should do is go and download your R software. Just say, just a moment. The later point. Thank you. Okay. R software download. Just give it in Google, and I think the latest version is 4.0.0. So just say R software download in Google. It will take you to the Crane website. Just click on that and say install. It will install. Once you have done with that, go and install R Studio. Download in your browser, and then it takes you to that RStudio website. Go and download for Windows. There's a free version, and most of my courses run on open sources. So that's the whole thing. Even on SAS, I use the academic version so that it's easier for people to download and learn the concepts. But then affording SAS software, you know what it is. It costs. So R and Python is what I generally use. For learning purposes, R is always better. That's what I feel. That's my opinion. From R, graduating into Python is very simple, because in R, we implement every step, we understand the intricacies and things that happen in the background also. Most of the time, what happens is we don't understand what exactly happens in the background, but the output is thrown at us, and then we are imagining what is really happening. So, what we need to understand is there are two things to this. One is a background process, and one is a foreground process. So, when I initiate a foreground process, it goes and triggers a background process which actually runs this. So I have to give you a very simple example. For example, let us say a student wants to take admissions at a college. Background process. What is the background process that is required? The background process that is required is he needs to push in the applications first. He makes some application payment, things like that, and then ultimately his parents pay the fees and things like that. And then all this has been happening in the background, which is nothing to do with the foreground process at all. Once this process is completed in the background, only then it comes to the foreground. The students start attending colleges and things like that. It's the same thing in the system also. So every program triggers another system call or ISR, and ISR triggers something else, and then the whole process works in the background. So here what happens is it goes and triggers another program, which is basically, I'm calling a function. It's just like a system call. That's, I hope you understand that. So I would not elaborate more on that. So the system call goes and calls that, executes that, memory pointer move to that particular memory location, executes that, comes back to the present position, and then again restarts the whole execution. So this is how the whole process is about. To understand about R, The software has been written by two professors at the University of Auckland in 1988, Ross Ihalka and Robert Gentleman. For almost 10 years, till 1998, these people have been developing it themselves, and then they found that they're not getting anywhere, and that's when they got it into the community, and we have seen how R has really grown in the last about 20 years. And that's the historical background of this thing. Another very important aspect about R to be understood is that most of the softwares like Excel, SQL, and all these have size restrictions, or they have the in Excel, if you take, you have 10 lakh records and you have 1024 columns. That's the restriction that you have, that is given by the software. And if you take SQL, we talk generally in terms of about 10 lakh records being stored on the data on the database. And we are talking in terms of big data also now. Any data that is more than 1 terabyte is defined to be big data. So essentially, what we are trying to work on is essentially on data that doesn't fit into big data, or it's small data, whatever you call it. So it should cater to both sets, but then there must be some architecture that sits in between them and does this. So R does not restrict at a software level the size of the data that can be given and processed in R. So what normally happens is it is based on the RAM size. You can go up to around 60% of your RAM space. That's the size of the data. For example, I have 15 million records, and say I have about 120 columns, and if I multiply these two with, say that the size of each of those values in each of those columns is around 8 bytes, and if I multiply it, it approximately works out to around 1.5 GB. So the that's the whole this thing. And R does not restrict the size as a software, but then the restriction comes from the hardware. If you have 8 GB, you can go even up to around 6 GB of data processing. If you have 16 GB, people go even up to around close to our on an Hadoop environment or in Spark, and then work. R works in the Hadoop environment, it works on Spark too. So once you learn the basic programming here, the same works there, only thing at the background processing is going to happen a little differently. So that's the only major difference between working on small data and big data. So essentially, if you understand how the small data concept works, same thing works there. No, there is only essentially only the architectural changes at the background. So that is about the architecture of R, talking about the size of the data set and things like that. Once we understand this point, the next stage is to start understanding the data types on R, essentially. The data types, since we know other programming character data, but R does not support strings and all those things. Everything is treated as character. And we have logical data, which is your Boolean information, that is zeros and ones. Number of repeating records, essentially, in a character column. Simplest example can be, say, we have about 29 states in this country. So each time repeating each of the states for each of the 135 crore population in this country in the database is going to be a difficult proposition. Instead of that, I can convert this column as a factor, and then internally it assigns index values. So accessing the index values, I can essentially link it up and do the whole process. So that's about factors. So what I told you is called as classes in R. So there are subclasses which is called as type of. We refer it to as type of in R. So in the numeric, we have what is called as integer. We have what is called as double, which is your floating point number, and then finally we have complex numbers. Essentially in analytics, we don't use any complex numbers since R is statistical tool. It supports even complex numbers. So we cannot have an imaginary root and a real root. When I say that I have 4i plus 1 revenue up this year or down this year, but I can say 4.5% the sales has gone up, the revenues has gone up. So that is something that I can say. So double is something that I would typically use in these scenarios, double and integer. And these are all called as type of. While character, the type of is again character because that is the lowest this thing that is available there. So class will also be R and subclass will also be R, which is type of. Numeric, when I talk about logical, it is true and false that we have, which is true is always represented as 1 and false being represented as 0. And then factors, of course, is when you take the type of a particular column, it will still say factor. So that doesn't really worry much. Another very important aspect of understanding R is that you don't have to specify the data types in R. It follows the precedence rule and then takes the data. So the lowest precedence is starting with the logical. Next higher precedence is with the integer. Next higher precedence is with the double. Next higher precedence is with the complex numbers. And then finally, the highest precedence is with characters. So following the precedence rule, whenever you give some type of an input, the data is going to be, going to get into that particular thing based on the data structure. First thing, before we go into data structures, let us understand why we would require data structures. We have been hearing about this maybe even right from our engineering days, but many of us might be knowing, many of us might not be knowing this concept. So I would like to iterate on this point, which is very important for the future of most of my programs. See, data exists in different forms at different levels. And essentially, one level needs to communicate with the other. So when you write your source codes, essentially, that's at the user level. And then the hardware doesn't understand, really doesn't understand this. So there needs to be an interpreter. So we have an interface in the form of OS, which talks in terms of assembly code. And then hardware talks in terms of, if I typically ask you the question, the answer will be at the hardware level, everything is in ones and zeros. But then for the real understanding, let me be frank that it's not in terms of ones and zeros. It is a state that we have identified based on the electrical component and the electronics component that go into making the system. Supposing, for example, if I take a fan either runs or does not run. Current passes through it, fan runs. Current does not pass, fan does not run. So there are only two states out there. So we are looking at a binary state. So that means we are making a representation that when it is running, it is in one state. When it is in off, it is in zero state. It is a representation that we have done for our understanding. But as far as the electrical device is concerned, it is passing of current and not passing of current are the two states that are possible at the component level. So what we do from the OS level is pass on this assembly data into the kernel core of the operating system, which is called as the kernel. In the kernel, we convert it into ones and zeros. Once this ones and zeros is formed at the kernel, which is the kernel level, OS level, kernel level. So we already saw three levels. One is a user level, one is the OS level, one is the kernel level. And from the kernel level, what normally happens is we are representing two levels of current. One is represented as plus 5 volt, other one is represented as plus 3 volts, because I cannot switch on and off the system at every bit. Wherever there's a 1, I switch on the system. Wherever there's a 0, I switch off the system. This cannot happen. So I am giving a 2-level voltage level to represent my ones and zeros. So even though current is passing through the circuit and I get a 3 volt as the output, it reflects back from the hardware level to the kernel level as a 0. If a 5 volt has come as a output at that bit, it reflects as a 1. So this is the processing that is happening. So data is represented in different forms at different levels, and each one has to connect to the right component back, and output has to be given to it. So for doing that, we use a specific data structure. We create a data structure and we say, take the data structure from the data from this place, put the output in this place. That is why we are defining that. So that there's a link between the process that goes in and there's a link to the output process. So this is the whole cycle internally that happens. And most of the time we would have studied operating system is separate, networking is separate, this is separate, and that is the type of knowledge given in most of the places. But then everything is really interconnected. And unless I understand the whole intricacy of things, my programming output really does not come proper. So since there are different levels of representations, we go for representing data structures, which is something like a bag where we push data and retrieve it. This is one point. Second point is for easy saving and easy retrieval. This is the second point why we use data structures. So in R, to look at the data structures, we have 4 in numbers. One is vector, second one is matrix, third one is a list, and fourth one is the data frame. And in all practical applications, we would be using more of the data frame rather than the other things. But then vectors and matrix are also very important. But then list, in a sense, in practical applications do not really work, because for every element I need to give an address and remember that. And if I have 4 variables and there are 60,000 employees for 60,000 employees in a company, and there are 4 different parameters for them, I need to have 60,000 into 4 variables to access each of those elements. So normally, in a practical sense, we don't normally use a list. But when I use a data frame, internally it is stored as a list. And then the data frame has got a mechanism. When I give a particular record, I address as if I'm addressing a vector, but then internally there's a mechanism to convert that and bring it out of the list. So that's the internal aspect of data frames. So before going to that, let us go. If you have installed your software, I would like to go and ask you to create some vectors, create some this thing. I'm going to give you a step-by-step instruction for that, and then see for yourself how exactly this is working. So that what we have been talking makes some sense to you. So if you are ready, I want you to open your R Studio now. Hopefully you have followed the sequence of installing the R software first and then the R Studio, because the R Studio works at the front end while it connects to the backend R and then works. Another very important aspect I forgot to tell you is if you have seen while downloading your R software, it was only about 80 MB in size. So this we call it as the core R. It is only to make the software as light as possible, because I don't want to hold all the features that are available in the world. Point number one. So that maximum data can be utilized, because our software has also to run. So we try to run a very small light version of it and then try to access more of data. That's major reason for making it light. Sometimes it will throw you an error that this particular package is not there, this library is not there. So you go install only those packages which are required for you, and then you run the whole process. For example, simple packages like base, which reads a text file, is something that we normally use to read text files. For reading CSV files, we use something called as base, and then read R. And then for reading Excel, we use Excel package. And then for reading SPSS, we have Haven. For reading SAS, we have Haven, and Strata, we have Haven. So using Haven, I can import files that have been stored on these software packages into R. So initially, it will not be there in this 80 MB of software that you have loaded. When you try to load an Excel file into R, it will ask for that particular package. So you go install that particular package, do your operation. Next, if I want to go and work with, say, a function like factor analysis, PCA, dimensional reduction, and all these things, we normally use a package called as Psych. PYSCH is the spelling of that package. We can even be using Factominer, or there are a lot of other tools which can do this particular thing. There are multiple packages doing the same functionality. Differences may be that they may be using some advanced techniques and faster executions and things like that at the background. So basically, most of them give you the same results. So understanding about packages is also one other aspect that we need to remember in R. So you keep on adding packages as and when functionalities keep on increasing, complexity of your projects keep on increasing. You load this package and then write your code. So that's the essence of this. So if you are ready with that, we will go and try to build a small vector. So on your R Studio, on the top right corner, there's a menu called as File. Click on that, and then go and select a new file and try to open a new R script file. Were you able to do that? So you have opened the new script file. So now I want to create a vector. So just to say v1, press your shift button and the less than operator and then the minus sign. Putting the arrow operator in R is the assignment operator. In some of the later versions, equal to is also supported, but certain times in practical applications I have seen and experienced that when I put an equal to, sometimes the object doesn't get created. So I rather stick to the arrow operator, assignment operator, rather than going for anything else. And there's a function called C. So after the minus sign, leave a small space, put small c. It's a small c, not a capital C. It's a small c. After C, open braces. Give the elements 1, 2, 3, 4 and close the braces. And position the cursor at the end. Press on Control and Enter. What is the output it is showing? Does it show on the console a blue line? If it is blue, then the execution was perfect. If it is in red, there is an error. So it will tell you what is the error. If you just type any errors that you are getting, I can support on that. And if you see on the right hand side, there is an environment, this thing. The object and the elements that you created inside that object would be visible for you. What is the function you used for, what does it say? Num set. Yeah, it's a number set, correct. Okay, this is done. If this is done, next say class of v1 or whatever variable name you have given to the object, give it within brackets. Class of, comma, that, it will give you the class. It will say numeric, essentially. And now go and type of, within brackets say v1, it says double, isn't it? Why did it take double even though you have given integer? Yes, it has worked with the precedence rule. As I said, double has got higher precedence than integer, and that is the reason why it has taken it as double. And another very important aspect to remember is a vector is a homogeneous data structure. That means it can accommodate a data type of only one type. It cannot have multiple data types. So essentially, let us go and look at keying in another object, say v2, arrow operator, small c, 1, 2, comma, within quotes ram, close the quote, then comma, within quotes sham, close the quotes, close the bracket, Control Enter. Once it is done, just type v2, position the cursor at the end of v2, press Control Enter. Now you would see a small change of how internally the elements are being saved. Everything is going to be in quotes. Even though the first two elements were numbers, the second two were in quotes. It is replicated to the first two. So that means internally the entire vector has become a character array. Now say class of v2 and see that it will be a character, and type of v2, it will be a character. Object name is always given within braces. Hmm. Is it done? Are you able to find the difference? Okay. Now you understand how a vector is getting created. So now let us go and say when I create the object, I want the entire object to be an integer. So now go and create a third object, say v3, arrow operator, small c, open the braces, say 1, comma 2, comma 3, comma 4. I'm sorry. After the arrow operator, say as dot integer, open the braces, then c of 1, comma 2, comma 3, comma 4, close braces, both the braces at the end, and then run it. Now run the class and type of for this object and check out. Are you getting that? Class would be numeric, type of would be integer in this case because I very specifically told as dot integer. Clear? Now let us try to find if something is of something. Now I said as of. That's because you said as dot integer while starting. Do you understand, Chintan? I said as dot, it should be integer. That's what I said. The first one that you created, it took double by the precedence rule. But when I'm creating the third object, v3, I very specifically said as dot integer and then created the vector. So I specifically made it into an integer. Clear? So this is for specifically converting one type to the other or creating a specific type of this thing. We use as dot integer, as dot double, as dot character, as dot factor, and things like this. Now if I want to find is this something, if I have to tell, then let us say is dot factor, open the braces, say v1, it will return Boolean values in terms of true or false. So in this case, it is not a factor and it is a double. So essentially your answer will be false or this output will be false. When you say is dot, when you check for something, it can be is dot integer, is dot character, is dot double, is dot logical, is dot factor. I can check. For checking, we use is dot. For converting it into a specific type or defining a specific type, we will use as dot that type. So this is how we build a vector. Now let us say how are we going to access specific elements in a vector. So object value, so that means the object name, say v1, open square braces, give the position you want to look at, close the square braces. That will give you the power to access individual elements within an array. Supposing I say 2:4, for example, then it will take from 2 to 4. When I give a single element, it will access only that element. When I say 2 to 4, it will take the series to second position, third position, and fourth position. So you can try that and tell me whether you are able to get that. So if you have got that, now let me go one step further. I want to modify the vector. So let me say I want to insert an element at the beginning of the existing vector. So what I can say is I have to create and reassign it into the same object. So I will say v1 arrow operator, v1 arrow operator, c of c open braces, give the new element of the first position, say comma v1, again open the square braces, 1:4, because we have 4 elements in the first array or the first object. So close the square braces and then close the braces that you opened after C. Say control enter, say v1, print the elements and check in the console. Got it? Now I inserted at the beginning. Now I want you to insert at the end following the same procedure. Instead of putting the new number before, put it after the square braces and check it out. I hope it is clear now with the syntax being put on the chat. So now I want you to do the opposite and insert a new element, say 40 at the end of the same v1 array. So syntax would change as something like this. since we have 5 elements now, because you have already run the thing. So now the new element 40 is what I'm giving there, closing this braces, and that's is what should be working for you. So you now understand how to create a vector, you know how to access a vector, you know how to insert elements. Now supposing I want to insert the element in between, say I want it to be inserted in position number, say now we have 6 elements there, so I want it to be inserted in the 4th position. So how do I do that? So for doing that, I will say V1, I'll put the arrow operator, C, open the function braces, I will say V1 of, I want it from the first element to the third element in this case, because I want the new insertion to happen at the 4th element. So the new element say is 50, I say comma, and then say again V1 of V1 square braces of 4th position to the 6th position. 6th position. Yeah. So this is how the syntax will look for insertions in the middle. See, always in a vector, I will be able to add new elements, keep on inserting and doing the whole process. Everybody is able to get that output, and if there are any questions, please feel free to type it out on the chat and I will answer that. Screen sharing actually was almost done, but there is some still some sharing issues here. If you see at my screen sharing, I'll just try to can see the window capturing is not typically happening actually. So, but the required softwares are downloaded, but I need to fix it up since I didn't have some time to do that. I have not done it today, but then it will be taken care in the live sessions. So you should not worry about that. That is an aspect that is almost taken care of, and that will be sorted out. I'm sorry for the trouble today because at last moment yesterday my system crashed, so I had to reinstall the old stuff. So okay. So we understand how vectors work now. So let's go and look at how we can create matrix. So say use different objects. Say I start with say E1 this time, and then use the arrow operator, use the matrix function, and then I will say 1:6 in this case. I'm giving a series. So that means it will be numbers from 1 to 6 in this case. Since I'm just talking about an example, I'm just trying to get you a picture of how exactly things work at. So next is to add the number of rows that I want. Say is equal to 3. N call equal to 3. So that's the syntax of creating a matrix. I hope everybody is able to at least view the chat. So now all you have to say is E1 and then say control enter. It will print the matrix. In some cases, the rows will be represented as R1, R2, R3, while columns will be represented as C1, C2, C3. Most of the cases, it will be like that. I hope everybody was able to create that matrix. As I told, when you execute the commands there on the script, why I put, I'm asking you to put those commands in the script is I can save it as a file, and then you can retrieve that at a later point of time. Whatever is typed in the console cannot be retrieved. That's the reason why I'm asking you to put it into a script file and then save it into a folder as an R file, .r file. So when you come next, you can just open that file and this thing. Another sequence I would request you to follow is before each command, put a hash and comment what exactly does that output do. What is the output, or why are you using that particular command? So supposing you learn today, and maybe after a year you come back and open that file, and then you read the command, it is as fresh as what you read. So that's something that I follow. So if you are interested in recollections at later points of time, then this may take a little bit longer when you are doing, but then you would spend a little bit of more time, but then recollection becomes absolutely easy. Next, let me say, always a matrix doesn't have a sequence of numbers. It may have different numbers. So what I would do is create another object, say E2. I will put the arrow operator there. I will say matrix. Inside the matrix, I create another vector. Say 30. Say let's go with a simple matrix where there are only 6 elements. And then I'm only specifying the row and then closing the braces in this case. I want you to see what is going to be the output there. It still works. It still generates this thing. See, you either specify the row or you specify the column. You either specify the row or you specify the column. Automatically, the other entity is taken up. If you specify the row, automatically it will take the column based on the number of numbers that you have. Whenever it doesn't equal, in certain versions, I have seen that warning is fine. Just type E2 and see what is there in the matrix. What is the warning it is giving? Can you just put it on the chat? Just copy and paste it there. Is the matrix created? And if it is having some issues, please put the warning. Warning is not a matter actually. Warning message in matrix C. Data length is. See, when I say 3 rows, that means the third column is the maximum. When the seventh element comes, it has to create the fourth column essentially, isn't it? When there are 6 elements and I said 3 rows, that means 1, 2, third, the second, and then the third column has to be created. For one element, you have to create the third column, and then 2 elements in the last 2 columns are missing. But then what it would have done is it would have repeated the first 2 numbers in the last 2 positions and created a 3 cross 3 matrix. And if it has created that, and then it is telling that you gave only this many numbers, but I have created this. That's the only warning. So that doesn't matter. And if you don't want that, then you have to reduce one of the numbers and then keep it exactly at 6 and then have 2 columns and 3 rows, or a 3 cross 2 matrix, whatever is the requirement. Clear? I hope that clears the point. So this is how you create the matrix. Now again, matrix is a homogeneous element where it can hold only one data type. It is either character or either numbers. Nothing more than that. 1, 2. At the time of creation, we are fixing at the time of creation of the matrix, we are essentially fixing the size of the matrix. So I cannot insert an element at the beginning or at the end or insert elements in between. That is not possible. But then I can access elements, and since it is a 2-dimensional element where there is a row and a column involved, I would have to access it something like this. This is how I access it. E of 2, 2. So that means I'm going to the second row and the second column element, and that would get displayed essentially. So this is how I create and I access, and I cannot increase the size of the matrix. That is the drawback that we have. And then lists, as I said, we would create something like this. So say R1 of list of say A is equal to say Jack, comma, say B. Okay, I'm is equal to say his age, then C is equal to say his salary. This is something I create, and you can repeat one more record like that by saying D, E, and F for one more person, and create the list. So this is the syntax we normally use in creating a list. So you can see for every object I have assigned an address, and when I say R1 of say A like this, it will print only what is there in A. So this is a very tedious way of accessing objects in the list. Main advantage of having a list is that the different data types can be accommodated. It's a heterogeneous data type in comparison to the matrix and the vector that we have seen just now. So since it is heterogeneous in nature, it is advantageous. In real time, we have heterogeneous data. If you take employee databases, you have name, age, address, salary, qualifications, whatnot, and each one has got different, each column has got different data types. For that, a list would not work, so we would go and use a data frame. So for creating a data frame, we can essentially create vectors for each of the columns that we want in the data frame and put it as part of the data frame. Now we created vectors. So let me go and create a simple vector. I will just say v1 and then say c of say 1 comma 2, or instead of saying v1 I would rather say that this is id, for example, something like this. After that, let me define a vector called as name c of Jack, comma George, that's it. And then I think after the Jack I put single quotes, it's a double quote, sorry about that. And then name, and one more vector I would create is age, c of say 20, comma 30. So one more last column, I prepare it as their salary, sal, c of say 20,000, 30,000. Execute the vectors, create the vectors first, and then I'm going to create an object h1 which is going to hold the data frame. Now I say data.frame is the function there, and then open the braces, and then I just say id, comma name, comma age, comma sal, closed braces, control enter, and now on the data frame object run class of h1 and type of h1, and check the difference. Your type of should be giving you a list because each column is created as a list. But what are the individual this thing? You can see by using a command called as a structure h1. It will display all the data types in this data frame. Check that and tell me if you are able to get that. Great. people are able to get it. So we understood what are data types and what are data structures and how it works in R. So the next step would be to go and look at how we can, since we have got only two records there, we may not be able to this thing. I will, when we are doing the actual program, I have a set of actual data files which is there in Excel and CSV, which we would be using to really look at all these things. Another last information that I would like to give you before we wind up this session is the summary command. You can say summary of H1 and see the output and then tell me what exactly it means to you. In the summary command, if it is a numeric column, it gives you the mean, median, it gives you the quarters 1, quarters 2, and quarters 3. It gives you the understand whether data is there under the normal curve or not. And so the more data sets, the more comparisons that you do, you would be able to figure this out essentially. Anyway, the point that I want to drive here is most of the sessions that we conduct will have a prerequisite which is talked in terms of a theory component. And once the theory component is over, we reinforce it with a practical component. Once we have done something in the class, you will have a whole set of assignments leading to that, which you will complete at your pace, of course. But then, if you really want to learn, by the next class, you should have completed the assignments, because one set of things leads to the other. And since we're trying to build, you see, we are trying to build step by step. I made you understand the data types. I made you understand the data set. Then I will make you understand how it means to work on a data set. Once a data set is done, how we do pre-processing of a data, how I will start from the CRISP-DM points essentially, how you understand the business vertical of that data set, how do you understand the data, how do you prepare the data set. Step by step is what we will be moving, and each component, practical component, will be there in each of the sessions. And once that is completed, we would be going and looking at the whole process of how to execute projects at the end. At the end of the course, you would be doing two specific projects that are instructor led, or I lead the whole project step by step, what you need to do, how it is done, what it means at every step to do something that I will lead you through. Then you are given two practice data sets which you need to submit at the end. And if this project set presentation you do very well, then I offer a free internship for 3 months to 6 months for people who have done this program. For people who have taken my advanced program, I typically offer a 1-year internship, which comes along with a 1-year experience certificate. For this is meant especially for freshers who are there in their final year or in the pre-final year students, is what I target for this 1-year program, because the course goes on for a period of around 3 to 3.5 months time, and then you start off and do real-time projects that we get through from our clients. I will be putting you on those type of projects and mentoring you on that. And that's how the whole process will be working. The other party is Ma'am was having a discussion that um, if for today you are able to provide some discounts, then uh, it would be great. So I already let her, I given her the my charges, discounted prices for today for people who register today itself. So you can discuss with her and come back. Apart from that, for any doubts, anything you really have, you can take my email ID and contact credentials, coordinates from madam and contact me. Hope this really helped you and understand how the delivery happens at CGN Research World and how we really prepare you to be um, armed for facing the corporate world day one once you um, complete the whole program. Apart from this, as a complimentary, I usually conduct a few placement classes where I would help you preparing for questions typically addressed on interviews, what people look at, and the way you need to answer it. And then you would be able to crack the interviews on your own. I don't have to really come behind you or talk to somebody and say, give him the job, he's my student, all this stuff. I don't have to do. Basically, the industry today looks at only skilled people. And with the next wave, the robotic process automation happening in a big way, we must get into the bandwagon either into data analytics, we have to get into either RPA, or we need to get into some of the trending things that really happens. My experience with academia and the industry that I worked with and now running my own firm is that data analytics comes from backgrounds of mathematics, statistics, neural networks, and other things. And all these concepts would never change. Unlike what has happened is during our days, we started with basic programming, then we went into Fortran, then we went into Pascal, then as an requirement, we studied C, we learned C++, we learned Java, we learned a whole gamut of languages. Now that is not the case. See, I essentially told you about our architecture. The same implies in Python also, actually. So if you learn one language in today's world perfectly, I'm telling, and don't tell me if there are students around in this audience, I would like to tell that in a semester, learning the entire C is not really possible. C has got concepts like pointers. So we basically don't understand what pointers are essentially because we didn't understand what our microprocessor teacher told us and how exactly pointers move from one end to the other. We have never understood. So writing pointer programs is something very, very this thing. And in C again, if I say, if as an interviewer I ask you why did a .obj file come there, we are not in a position to answer that because we don't know the levels, user level, OS level, kernel level, and hardware level that I was talking to you. So basically, in an OBJ file, we would rather have the assembly code put there, which is there, and then in a link file, all address sensitive instructions, where instructions are case sensitive pertaining to address, where you give a loop and all those things. Those type of links are maintained in that. And then finally, the exe file, which you say is ones and zeros, is supplied to the hardware, which converts that into +5 and +3 volts, and the whole process of compilation happens. But we don't understand this concept at all, why the compiler is working, why exactly it happened, what exactly it is doing. We don't understand in the background at all. But then, as far as this is concerned, the R or the Python is concerned, I'm pretty sure I said we are putting a core R. Wherever there's a new requirement, I add the new thing. For example, in Python, when we want to do analytics, we add a package called as pandas. When we want to do visualization, we do matplotlib, and a few other advanced packages have come in. So we just add that, and the basic coding of Python or R remains the same. There is no change. So that means even if something new is going to come into the market, I don't have to really go and change my platform. I don't have to really change my understanding. I have to just access the right package and the right tools at the background or the right architecture at the background and do the whole process. So my assumption and my optimistic view is, at least for the next 15 years, if you learn data analytics, you don't have to worry. And that too, as you go forward, if you add it with robotic process automation, you are the key guy to be surviving in the industry, because as students you still have 30 to 40 years to lead for the service. For those already on jobs, maybe you are still away 20 years or 25 years or 15 years or 10 years, maybe whatever may be the case. Still, next 10 15 years this is going to survive, and I think you should bet something on something that is going to be longer in the industry rather than short lived. And another very important aspect is most of the things are now working on framework. So really, as we go ahead, if we learn a framework, that's more than sufficient essentially, and most of the coding will be done. For example, Java, people are asking for Laravel and Marvin and all these frameworks essentially, and you don't have to write really Java code. You have to just pull objects and put it there, and then the uh, whole code is created. So frameworks are becoming the key this thing. So coding time and project turnover times are the main aspect that is reducing in the industry, and that is what you need to really see. So I suppose that I can expect people coming up and taking up the course, and wish you all the best in all your endeavors. And thanks a lot for joining us. On behalf of the CGN family, I thank you for joining us today, in spite of being a Saturday and the end of the day too. Thanks a lot. That's it from my end. Yeah, next time I will take care that it's more interactive, and this thing I would also install a particular software that I saw in the afternoon today, that where I can get voice from your end also on the this YouTube this thing. Main choice of going in for YouTube was, even if a lack of people join on the stream, it still works and does not crash, unlike meeting rooms that are given by other companies. And especially Zoom, I don't want to use because of a lot of security reasons and things like that. So that's the reason why I gone to the YouTube studio and uh, delivered this session and done the whole process. If it has been informative and if I have made enkindled your thinking, I'm happy for the day. Thanks a lot.